create the function by moving x cubed to the other side. Then we have to say that f of x is continuous everywhere as a difference of two functions. I'm missing a word. Of course, because we know that the difference of two continuous functions is always continuous. Very good. Now, we have to find f of something and f of something else, and we have to put the function in the graphing calculator and punch in some numbers. The interval is not given to us. Ready? Ready? So in y equals, please delete whatever. Make sure that go to the mode. The mode has to be in radian. Please make sure that you have your mode in radian. And go to y equals. So it's cosine x, close the parenthesis, minus x to the third power. And then go to second and table. And let's punch in some numbers. Okay, I already see what's happening here. So let's say 0 is positive, 1 is negative. That's all I need. I don't need to go beyond that. So I'll say f of 0, positive, and f of 1, negative. So the interval is 0, 1. Therefore, by IVT, I will find C in the interval 0, 1 such that what? Such that f of C is 0. The function is continuous on the interval 0, 1, and it's it changes sign. Yes? Huh?
When you punch in the values, like you always do, like 0 and 1, or like close to there.
It just happened. I'm going to start somewhere around 0.
Okay.
The solution may be somewhere between 10 and 11, but I'm going to start.
Would there ever be an instance that's like far bigger than that?
No, I mean, that will not be an exercise for a test situation. Greg?
Does that say everywhere is it different? Or
It says f of x is continuous everywhere as a difference
difference.
of two continuous functions.
All right.
Cosine minus x cubed, two continuous functions. Very good. Anything else? Okay, 2.6. Limits at infinity. Okay. Some time ago we looked at something like this. Limit as x approaches 0 from the right of 1 over x, and we said this was, remember the graph? You have to picture the graph right away of 1 over x, so the answer is we have to picture the graph, right? We graphed this several times by now. This is the graph of 1 over x. I'm expecting you to think in these terms. You make your life easier. So what is it? Perfect. But this was the result. This is not limit at infinity. This is the infinite limit. The result is infinity. So when we talk about limits at infinity, we are talking about limit as x approaches infinity from 1 over x. This is what we mean by limits at infinity. When x approaches infinity. So please look at the graph now and tell me the answer. Excellent. Which means that y equals 0 is a y equals 0 is a horizontal asymptote. Here x equals 0 is a vertical asymptote. What if I have limit as x approaches negative infinity from 1 over x to the third? What will the answer be? I'm dividing a pie by 10 billion people. What do I get? How much will you get? How much anyone will get? Exactly. Absolutely. Of course, y equals 0 is a horizontal asymptote as well. Okay, I would like to practice this. Different situations for infinite limits. Meaning when x approaches infinity or negative infinity. This is a different type of story. And here they are. Please choose anything you want. Let's not take too much time in choosing, so please feel free to say, I have to show a radical, either like this or like this. I prefer both, actually. So something like that. I have to show a polynomial over a polynomial, which is a rational function. I would like to show the arctangent. I would like to show the exponentials, at least. These are the most representative ones. I mean, I can use 2 hours on just these ones. Yes, any preference? Yes, so we're going to do 20. Very good. What else?
30.
Okay, we want to do 30, 20 and 30. However, I will start with 18 and then we'll go to 20. So for now, for a few minutes, we're going to practice these limits. So this is problem 18 on page 141. Ready? Last night, again, with my class, I had the same situation. I could not record because something happened with the system. So I'm looking to see what I did last time. I kept the last few pages, so I can also do this, so I can post the video for them too. Okay, so limit. I'll post this video for that class as well. Plus 6x squared minus 2 over 2x to the third minus 4x plus 5. And this is the limit as x approaches negative infinity. So initially, like before, I'm going to ask you, what is this limit all about? And you will say, I'm sure, that when x approaches negative infinity or infinity, these terms are too small to mention. These are the powerful ones. These are too small. I don't even care about them. So obviously, it's infinity over infinity, or negative infinity over negative infinity. It doesn't matter. This is one of the indeterminate cases. So for now, we'll start a list. There are 7 indeterminate cases. One of them we've seen before, 0 over 0, in which we would never be able to conclude. The second one we are seeing right now, and the other 5 will come in shortly, not today. Okay, so it's infinity over infinity, and this is how we will address this situation. Can anyone give us the degree of the numerator? Yes, we are going to factor out x cubed. Even if x cubed is not a common factor. What is the degree in the denominator? Which is not connected to the degree of the numerator. We don't care what it is. We don't want to mess this, mix them up. It is x cubed, it is cubed, so good. So now please give me 3 terms at the top and 3 terms in the denominator, such that if I redistribute x cubed times this will be 4x cubed times the middle term will be this, and so on and so forth. So, what will you say?
4.
You will say 4 plus. Excellent. Noah, thank you. Minus. Excellent. X squared. Very good. It is x cubed, you're right. For some reason, I thought there was an x, 2x, but no, there is no 2x. Good. What about the denominator? The same way, 2 minus 4 over x, this is x squared, and plus 5 over x cubed. Very good. Now look at this situation, and I'm going to ask you, what do you think I'm going to do next? And you will say, I know what you're going to do. You are going to simplify what? Which one? I mean, there is no discussion there, right? I mean, I see an x cubed and as a factor, and I see an x cubed as a factor. They're gone, right? Very good. Only when x approaches infinity or negative infinity, where does this go? Where does this go? Where does this go? And where does this go?
0.
All of them. And therefore, what is the final answer?
2.
4 over 2, which is 2 indeed. Therefore, y equals 2 is what? Horizontal asymptote. Excellent. Okay, so Eddie wanted to look at number 20, so let's look at number 20, which is limit as x approaches infinity from t minus t the square root of t divided by 2t to 3 divided by 2 plus 3t and minus 2. Minus 5. Well, how do I come up with these numbers? It's an identical situation with the previous one. However, just the power is a fraction. But everything is the same. So now I have to rearrange the numerator a little bit. Limit as x, it's t, of course, as t approaches infinity. So this is t minus t to 3/2. Do you agree? Copy the base, power 1 and power 1/2. So t times t to 1/2 is t to 3/2. Copy the base at the exponents. Agreed? Okay. And this is 2t to 3/2 plus 3t minus 5. And of course, I'm going to ask you the same question. What is the degree at the top and what is the degree at the bottom? You have to say, wait a minute, they are not polynomials. And I'll have to shut up because you're right. So I cannot ask what is the degree because they are not polynomials. So I will not ask that question, but I will ask you, what will you pull out from the top? And of course, when you plug in infinity, this will be negative infinity, this will be infinity, so it's still an indeterminate case. And I think I made the point. We started with infinity over infinity, and we ended up with 2. So that's why this is called an indeterminate case. You never know what you come up with. Okay, so it's not an undefined case, it's an indeterminate case. So, of course, I will factor out what? I can't say the degree because they're not polynomials. But obviously the highest power is 3/2. So now let's see what is left. From 1, we subtract 3/2. 1 minus 3/2 is negative 1/2. So t to negative 1/2 minus 1. 2 plus 3. Again, 1 minus 3/2 that we have in front is the same thing, t to negative 1/2. And minus 5, t to negative 3/2. Yeah, they want to be tricky here. T to negative 1/2 is a fraction. Where will this go when t approaches infinity? This is also a fraction. 3 over the square root of t. Where will this go when t approaches infinity. Same thing here. 5 over 3, the square root of t cubed, of course 0. And the final answer is negative 1 over 2, which is negative 1/2. So y equals negative 1/2, horizontal asymptote. And I'm going to have to say at positive infinity for this one. It's not a rational function. I have not discussed anything on the other side, and then the other side will not be defined because the square root of t to the third would not exist on the negative side. Okay, so any questions on these problems? Anything? Anything? Yes, please, Eddie?
Is this from what you were telling us earlier, where we can basically bring the limit in, so you're
No.
finding the limit of
No,
each one?
I did not swap the operators. No. The function stayed outside, inside, the limit operator was outside. I did not swap the operators. Not yet. We're gonna do that when we, in logarithmic differentiation. That's in the next chapter. Not, in this chapter, we're not gonna use that theorem other than the limit laws. Okay, I forgot what you picked, but I have to pick 24. You'll see in a minute why. These are not easy to handle at all. They require a lot of steps. They require a lot of attention. Before we proceed here, I need to ask you a question because I need to refresh your memory on something else. I'm hoping that you are collecting all these pieces of information in your tiny notebook and you're looking at it every day or every other day, whatever, right? This is very important, all these. So here's what I want to refresh your memory on. What is the answer here? Excellent. Thank you. What you really mean is this, which is indeed this. Awesome. Thank you. Be careful. The square of x squared is not x. Careful. It's x if x is greater than or equal to 0, or negative x if x is less than 0. Very good. So keep this in mind, and let's start working on this limit. Okay, let's start with the denominator because it's easier. What is a degree? I can ask you about the degree of the denominator because that is a polynomial. Yes, so we have to factor, and what is left in parentheses? Excellent. Now, I cannot ask you about the polynomial of the top unless I say, under the square root, there is a polynomial. I need that degree, the degree of that polynomial, which is?
3.
Under?
Oh, under this radical, it's 6.
6. Very good. Awesome. So we factor out x to the 6th. And please tell me what you have left in parentheses. Excellent. Do we all agree with that? Yes? Awesome. Good. Stay with me, please. Now, this is a product. I'm allowed to take the square root from the first factor times the square root of the second factor. So remember, the square root of AB is the square root of A times the square root of B. So I'm going to use that property. Limit, as x approaches negative infinity, the square root of x to the 6th times the square root of 9 minus 1 over x to the 5th over x cubed, 1 plus 1 over x cubed. Now the moment of truth. Coming back to this definition. When I take the square root of x to the sixth, I get x to the third. But x to the third could be positive or negative. But now I'm looking here. X approaches negative infinity. So then the square root of x to the sixth will equal the positive x cubed or the negative x cubed. Very good. The negative x cubed because of this. Awesome. So the next step would be limit as x approaches negative infinity from negative x cubed, the square root of 9 minus 1 over x to the fifth over x cubed 1 plus 1 over x cubed. So please be very careful. When x approaches positive infinity, then you don't need the negative. But if approaches negative infinity, you need a negative x cubed. Okay. Yes, Greg?
How is the square root of x to the sixth x to the third power?
6 divided by 2.
Oh,
The
okay.
power divided by the index.
Okay.
Very good. So now we're going to do what? Yes. Where does this go? Only because of this. Because if it goes to 5, 1 over x to the fifth is not going to go to 0, right? But because x approaches negative infinity or infinity, this will go to 0. And this will go to? Good. And the answer is? With minus in front. Very good. Negative 3. So then we conclude that y equals negative 3 is horizontal asymptote at specifically where? No, because that's what we determined. Only. It will not be negative 3 if x approaches infinity. It will be positive 3. Any questions? Any questions? Yes, please. Noah?
So like, just with these two that we just did, could you just look at the 9 and the 1, like the whole time? Like in the very beginning, like.
Yes, but then you will say it's positive 3, but actually it's negative 3. Be very careful. Yeah. Because of the absolute value. Because of the absolute value here is which is the answer is the absolute value of x to the third. But when x approaches negative infinity, I have to have negative. Yeah. I would like to look at that arctangent because this is extremely important. I want to review with you those two graphs. So this is 33 on 141. So this is limit as x approaches infinity from arc tangent e to the x. And then I don't remember what you chose. I think you chose 30 and I would like to do 34 as well. Any questions for me? Please stop me anytime. Okay, ready? We already, okay, so I'm given this limit. What is the first thing? I have to see what it is. Because it could be any of the 7 indeterminate cases. So when x approaches infinity, first I go to the inside function. This is the inner function, and this is the outer function. First function, second function. This one is evaluated first, this one is evaluated next. So e to the infinity. We know the graph of e to the x, we just talked about it. Where does this go when x approaches infinity? Yes. So now I need to think in terms of arctangent. This is another very important graph. Please add it to the list. Here's the graph of arctangent. Here comes the graph. We need to remember this graph, please. Arc tangent x is the same with tangent inverse x. Please do not say that this is 1 over tangent. This is just a name, a different notation than this. They are the same function, but different notation. This is not 1 over tangent. This is the inverse tangent, the function that is the inverse of tangent. Or you say arc tangent. Okay, so stay with me. So I know that when x approaches infinity, this quantity approaches infinity. Now I have to determine what happens to arc tangent when x approaches, or when the value inside approaches infinity, or the argument. Pi over 2. Excellent. So y equals pi over 2 is the horizontal asymptote at infinity only. Questions for me? I can get rid of this. I just want to make sure that I'm going over the last two problems that I did with them last time. So I can post this for them too. Okay, so now I think you said, or I said 34, and then you said 30. Okay, very good. So we'll finish with these two. I know I have 6 minutes left. So there may be a class starting from 7 o'clock, so we have to leave early. I mean, not early, you have to leave fast. If that's the case, I don't know. Maybe they went to another room. So limit e to 3x minus e to negative 3x divided by e to 3x plus e to negative 3x. Of course, when x approaches infinity, we're discussing limits at infinity. Okay, so when x approaches infinity, can anyone tell us where does this go? Because it's going to be 1 over e to 3x.
0.
Yes, indeed. This will go to 0. I don't want to circle it here, though. So where does this go?
0.
Good. But where does this go?
Infinity.
Yes, and this 1 to infinity. So the problem, again, is we encounter the same situation in which we have an indeterminate case that's infinity over infinity, and no one has a clue. I'd like to say that. You may. Okay, so I will factor out the largest of the two, which is e to 3x. It happens to be e to 3x in both. Now we have to be very careful. It's the same procedure we used before, but we have to be very careful what we write inside. Of course, one is minus and the other one is positive. But what do I write? Obviously, this must be 1 in both cases. Now I have to be careful here. So from negative 3x, I subtract negative 3x. So I get e to negative 6x. From negative 3x, I subtract negative 3x, and I get e to negative 6x. So let's check this, in case you have any doubts. E to 3x times 1 is e to 3x. When I multiply these two, I copy the base and add the exponents, and I get negative 3x. I copy the base, add the exponents, and get e to negative 3x. Agreed? Of course, you're going to tell me, I know what you are going to do next. What am I going to do next? And I'm going to ask you again, where does this go? Very good. Where does this go? And the limit is 1. So y equals 1 is a horizontal asymptote at infinity. Any questions? Any questions?
Is it only at infinity, right?
Yes.
Yeah.
So finally, and I'll stop after this. We're looking at 30. So we have limit as x approaches infinity, e to negative x plus 2 cosine 3x. Where does this go? Yes. Where does 3x go? Where does 2 times cosine of infinity go? Cosine does not approach a number. It will go on forever. It will not approach